Okay, good day. My name is Dr. Jafar Alavi. I'm the instructor for this online Economics 2070, which is Quantitative Methods for Business #1. Most of this course is basically algebra and a little bit of calculus toward the end. So those of you who have had high school algebra, you should be fine. But still, you need to pay attention to the lecture, and also there is video of exercises and end of chapter exercises separate from this one. Please go to those and watch them. This is going to be exclusively the lecture video series. The book we are going to use is called Applied Mathematics for Managerial Life and Social Sciences, and it's written by Sue Tan. Very good book, and all of that book we are going to use basically 4 or 5 chapters of it. At the bookstore here at ETSU, they sell a custom version of it, and however you can buy it online. You can buy it from webassign.net, which is, by the way, the site we're going to use for you to take the quizzes, which would make out your grade. About 20 or so quizzes you have to take, and that would determine your final grade. So the first thing you want to do is go to webassign.net and using the key I provide you in the syllabus to register. You have to pay for the access to WebAssign, and there's also ebook that come with it, or you might have to buy it separately. I don't know. They do that differently at different times. If you look at the monitor here, when you register after the course opens, down where it says about this class, it will show you the textbook, Applied Mathematics for Managerial Life and Social Sciences. Right now we are using the 7th edition. It might be other edition which would be used later on. If you click on that, it would bring up the ebook. And in this ebook, you can go page by page and different chapters. So for example, the first chapter, which is the chapter we're going to cover, the first section of it called Real Numbers, that's 1.1. So you have the content of the chapter in front of you. The ebook is very helpful to read. In addition, next to topics, you would see this camera logo. If you click on this, actually bring up a lecture about that section, which is done by the book publisher. So I'm going to click on this just to show you for a second. A new window would open up. It's called Introduction to Real Numbers. You click on it, and the video begins. It's basically the same thing I'm going to go through. Maybe there are some differences. So it would be good if you do all both of them, my lectures and the lectures down here. Another way you can get to this, if you go on top of this page and click on media, it will give you the chapter 1 media. For example, here is chapter 1, Introduction to Real Number, which is the one we just saw. Use of number line. You click on it, again a video would come up, and is continuation of the lecture in this chapter. Very helpful, all of them. So again, log into webassign.net, register using the key, the class key provided to you, and from there you can see all the scheduled assignments, which is basically the quizzes, and with the date, the due date, and also each one of them would have a time limit. You have to take it within a time limit. So once you open a quiz, you have to sit down and finish it. All right, Now that we have that out of the way, let's go to the lecture. As I said, the first chapter is Fundamentals of Algebra. Again, those of you who have had high school or college algebra, you would be familiar with everything here. So this would be a review for you. The topics we're going to cover in this chapter includes real numbers. And by the way, when you look at the textbook, each section is labeled as 1.1, 1.2, 1.3, and so on. I think the first chapter has 9 different sections, which at the end of each section, there is a set of exercises that you can do on your own time. And also the quizzes come from those exercises at the end of each section. Continuing, real numbers are the numbers we use in everyday life, whether they are positive, negative, decimal, fraction, whatever kind of numbers we use is called a real number. Then we also talk about polynomial expressions, algebraic expressions, they are also called, and how to factor these polynomials. That would be another section in this chapter. Rational expressions would be explained, and how to simplify rational expression. Another topic, integer and rational exponents. We talked about exponents, like x to the 3rd power or 5 to the 15th power or whatever. The exponents would be discussed. And solving equations, whether it is a simple linear equation or it is a quadratic equation, which means the variable has a power of 2. We do not go beyond power of 2 for solving. And finally, we talked about inequalities and absolute value and how to solve equations or actually inequations, solve for a variable such as x. And the same thing with the absolute value, how you define absolute value, what it means, and ultimately solve for a variable using absolute value. So first, real numbers. Again, as I said, real numbers are the numbers we use in everyday life, and they are divided into 2 groups. One is called rational numbers. In this picture, in the Venn diagram, is shown as Q, and irrational numbers. Okay? Under rational numbers, the smallest subset of rational numbers is called natural numbers. Natural numbers. Natural numbers are whole numbers from 1, 2, 3, 4, 5, 6, all the way to plus infinity. So all the positive numbers, whole numbers, starting from 1 going to infinity is called natural number. The next level up is called whole numbers, or W, the whole numbers. The whole numbers are the natural numbers and include 0. So it has to be 0 and positive numbers. So 0, 1, 2, 3, 4, 5. This would be what we call the whole numbers. The next subset of rational number is integers. Integers are numbers, whole numbers, positive and negative. So it goes from negative infinity to positive infinity, including 0, and it has to be whole number. It should not be any fraction or a decimal in there, okay? So minus 10, minus 15, minus 34, plus 0, plus 25. All of these would be called integers. They have to be whole number. And the next level up, the rational numbers. The rational numbers are numbers which may have decimal point in it. It might be in the form of fraction, in the form of decimal point, okay? So for example, on the rational number, you would have 1.56. That is a rational number. Minus 3.2. That is a rational number, okay? Now, irrational number, this irrational number. Irrational numbers are numbers that have decimal point, or it's a fraction, but it's not terminating in the form of a decimal point. For example, if you have pi, pi is an irrational number, right? Because pi value is 3.14 and it continues with different numbers. It never terminates at the end. You can go to, I don't know, 2,000 digits to the right and it would never terminate. That would be irrational number. Square root of 2, use your calculator and find out what the square root of 2 is. That would also be an irrational number. Okay? I said something about the repeating decimal. If you have a repeating decimal, that is actually a rational number. So for example, 10 divided by 3, that is equal to 3.33333. Since this is repeating the same pattern, 3333 on the right-hand side, then that would make it a rational number. Even though it's not terminating, but that would be a rational number. Now we're going to show this on what is called the number line. A number line is a straight line you have, such as this one, straight line. To the right, you go to plus infinity. To the left, you go to minus infinity. And in the middle, you have 0. To the right of 0, you would have all positive numbers. To the left of 0, you would have all negative numbers. And you can show any number on this number line. So for example, if you want to show graphically where 4 is, you would say, okay, 4 is right here. And any other number you want, such as minus 1.87, 0, square root of 2, 4.55. So any real number you can imagine, you can show it on this spectrum from minus infinity to plus infinity on the number line. The laws of real numbers, very important to know. The first law is called cumulative. Is the addition law says a plus b equals b plus a. Okay? So if I wanna write this, so what I'm saying is 2 plus 3 is the same as 3 plus 2. Both of them would be 5. It doesn't make any difference whether you say 2 first or 3 first. 2 plus 3 is the same as 3 plus 2. Now, in the multiplication, again, a times b equal b times a. Again, a and b are real number. So this would be 2 times 3 equal 3 times 2. Both of them would be equal to 6. Now, another law of real number, the second law, associative, would say that a plus b plus c, a plus b in parentheses plus c, would be equal to a plus parentheses b plus c. We already assumed here a is equal to, let me write this down, a is equal to 2, b is equal to 3, and let's say c is equal to 5. So we can use these numbers to prove that this associative law is correct. So a plus b, that would be 2 plus 3, plus c, c we said is 5, is the same as a, which is 2, plus b plus c, which is 3 plus 5. Now you can see here 2 plus 3 is 5, and 5 plus 5 is 10. So on the left-hand side you have 10. On the right-hand side you have 2 plus 3 plus 5. Well, first of all, 3 plus 5 is 8, and plus 2 would be equal to 10. So 10 is equal to 10. So both sides are equal. In terms of multiplication, again, the law would hold. And a times b times c equal a parentheses b times c. So again, you can say 2 times 3, the whole thing times 5 is the same as 2 times 3 times 5. Okay? So if you multiply 2 times 3 is 6, then 6 times 5 is 30 on the left-hand side, equal. 3 times 5 is 15. 15 times 2 is 30. So 30 would be equal to 30. The identity law for real numbers say if you add a 0 to a real number, that doesn't change the value of the real number. So we are saying a plus 0 is equal to a. So 2 plus 0 is equal to 2. In multiplication form, if you multiply a real number by 1 is equal to the same real number. So 2 times 1 is equal to 2. So when you multiply anything by 1, it doesn't change the value. The fourth law of real numbers, the inverse law, it says a plus negative a equals 0. So if you add a number, if you add to a number a negative of the same number, that would end up with 0. So in this case, you say 2 plus minus 2 equals 0. And that is correct, right? Because that would be 2 minus 2, that would be equal to 0. In the form of multiplication, it says if you multiply a real number by its inverse, it would be equal to 1. If you multiply a real number by its inverse, it is equal to 1. So 2 times 1/2 would be equal to 1. We know that is correct also. Last, distributive law of real numbers. If you have a multiplied by b plus c, which is in parentheses, that would be a should multiply by b, that's ab, and a should multiply by c, that would be ac. So again, let's use some numbers. 2 times 3 plus 5. We say that is equal to 2 times 3, that is 2 times 3, plus 2 times 5. So let's see, 3 plus 5 is 8. So 2 times 8 is 16. Now 2 times 3 is 6, plus 2 times 5 is 10. Therefore 16 is equal to 16. So that's a proof that the distributive law works. Properties of negatives. First, a negative of a negative number is positive. A negative of a negative number is positive. You can see it here on the slide. Negative of negative a is equal to a. Such as negative of negative 2, that would be equal to positive 2, right? Let me show on the right-hand side. On the right-hand side, as an example, they have negative of negative 3, which is equal to 3. Negative a multiplied by b equal negative ab, or a times negative b. So you can put the negative anywhere you want. So negative 2 times 4 is the same as negative, in parentheses, 2 times 4 is the same as 2 times negative 4. All of them would give you negative 8. Next, negative a times negative b would be positive ab. A times b, negative times negative would be positive. So on the right-hand side, we will have ab. So negative 7 times negative 8 equals 7 times 8. And finally, negative 1 times a equals negative a, such as negative 1 times 9 equals negative 9. So if negative 1 is multiplied by anything, it changes the sign of that. Okay. Now in this example, a, b, and c are all real numbers. They could have been variable, and still the same law would hold. So for example, I say negative of negative x, that would be equal to positive x. This is the first law. Then I say negative x times y, that can be written as negative xy, or x times negative y. I can do that, so I can use two variables, x and y, and apply this same property. Next, negative x times negative y, that would be equal to xy. That's this property. And finally, -1 times x, that's equal to -x. That is this property. So whether it is real number or it is a variable such as x and y and whatever variable you may have, these negative properties would be universal for both of them. Properties of 0. Property number 1, 0 times a real number, in this case 0 times a, is equal to 0. 0 times any real number, whether it's positive or negative, fraction or not, when you multiply with 0, is equal to 0. So that is the first property. So you say 2 times 0 is equal to 0. Even if you had a variable such as x, so x times 0 is also equal to 0. So that will go across to a variable also. Second property says if a times b is equal to 0, then either a is equal to 0 or b is equal to 0. Okay? If two real numbers is equal to 0, is either the first number has to be 0 or the second number has to be 0. So this would apply again to a x and y, for example. If we see x times y equals 0, that means either x is equal to 0 or y is equal to 0. We're going to use this in solving the equation very soon. You're going to see this application of this properties involving 0. Now we get to the next section, which is polynomials. First, before we get to that, let's talk about exponents too, and then we get to polynomials. Exponents, it says if you have a to the n power such that n is a positive integer, so it has to be a positive whole number, so that's 1, 2, 3, 4, so on and so forth. A is called the base and n is called the exponent. That's the power is called the exponent. The definition is that a to the n power is a multiplied by itself n times, or n factors. So 2 to the third power is 2 multiplied by itself 3 times. So 2 to the third power is 2 times 2 times 2. As an example here, it gives you, it says 5 to the third power is 5 times 5 times 5. 5 times by itself 3 times. That is 125. The first property of exponent, there are other properties we will see later on, but the first property of exponent says if you have a to the n power multiplied here by a to the m power, it has to be multiplication, right? A to the n power multiplied by a to the m power, you write one base, so it has to be the same base, you write one base and add up the powers. So for example, 2 to the third power multiplied by 2 to the fifth power, that is equal to 2 to the 8th power. You add up the powers, okay? Only when you have multiplication. Here they use a variable x. It says x to the third power multiplied by x to the fifth power, that is x to the third plus 5. 3 plus 5 is 8. So that's one of the properties of exponent.